The project title is EnReal and Energy Aware Resource Allocation Methods for Scientific Workflow Executions in Cloud Environment. In the existing system, in existing state of the art methods, that is, the greedy task scheduling algorithm presented in the energy aware greedy algorithms presented. Next, greedy doesn't take the PM mode switch operations into consideration we designed. The problem of resource allocation is treated as a bin package problem. The the process spends the time in the ready queue for the waiting of processor for implementation is known as waiting time and the time the process completes. So, completing the process produces higher average waiting time, the main disadvantage. If process is executed in circular way, then more context switches occurs, so throughput will be low, which leads to overall degradation of system performance. This action, which is performed by the scheduler, is known as context switch. Context switch leads the wastage of time, memory, and leads to scheduler overhead. The disadvantages of existing system are: there is larger waiting time and response time, there is low throughput, there is context switches. The proposed system are, generally speaking, multiple scientific workflow executions need to be deploy, deployed simultaneously in cloud environment without loss of generative workflows. We can observe from these results that our proposed EnReal method, which with both migration and with PM mode switch operations, achieves better resource utilization with the increasing of arrival instance of time partitions and compressed with the existing method 6 data sets. The energy consum consumptances in triggered at different arrival instance of the identified time partitions. The simulation results in this experiment. The timer will be allocating the each process of fragmentation, and each process is executed in allocating time. If one process is run within timing, another process is waiting for next priority timing. Advantages of proposed system are: there is fairness since every process gets equal share of CPU. The newly created process is added to the end of ready queue. A scheduler generally employs time sharing, giving each job a time slot or quantum. Alternate titles for these is EnReal and Energy Aware Resource Allotment Technique for Logical Deal Flow Execution in Cloud Location. Power consumption estimation models for processors, virtual machines, and servers. Energy energy reserve. The next one is energy resourceful consumption of resources in cloud computing systems. Future enhancements are: an energy aware resource allocation method has designed for virtual machine allocation to support scientific workflow executions. At last, extensive experiment evaluation using the Cloud Sim toolkit has been conducted, and the result have demonstrated the validity of our method Based on the work done in this paper, we plan to integrate our energy aware scheduling of scientific workflow executions into real world cloud platforms in the future. System requirements or the software requirements are: front end is Visual Studio .NET 2010, code behind C Sharp.NET, backend is SQL Server 2008. Operating system needed is Windows 7. Hardware requirements are hard disk 40 GB, RAM is 512 MB, processor is Pentium 4, monitor needed is 17 inches color monitor. Thank you.